In this video, I'm going to talk about the mean value theorem. Okay, so mean value theorem is still under section 3.2 of the book. So I had the previous video, that is the Rolle's theorem, and this video will talk about the mean value theorem. Okay, what does it say? If a function f is continuous on the closed interval ab and differentiable on the open interval ab, then there exists a number c in AB such that f prime of c, it is slope of the tangent at the point c, at the number c, is equals to fb minus fa over b minus a. What is that? This is basically, this is bfb, this point is bfb, this point is afa, right? Because you see that point is bfb and that point is afa. So that point is AFA, this point is BFB. So what is the slope of the line joining this point and that point is FB minus FA. So y2 minus y1 over x2 minus x1. So that's the slope, right? What does it say? It's basically, so if a function is continuous in the closed interval AV and differentiable in the open interval AV, then you will be able to find out a point C between A and B such that the slope of the tangent line, or the tangent line at the point C, is parallel to the secant line joining that, because the slope is equals to the slope of the secant line, right, joining the endpoints basically. So this is in other words, you can see that if f is continuous on the closed interval AV and if f is differentiable in the open interval AV, then you will be able to find out a point C between A and B where the slope of the tangent is equal to the slope of the secant line joining the endpoints. That's what it says, right? Slope of the tangent line at C, that's C, right, is equals to the slope of the secant line joining the endpoints. In other words, this is basically, this will give you the average velocity, right? This is the instantaneous velocity, this is the average velocity. So if you want to describe that way, then it will be like, if a function is continuous in a closed interval and differentiable in the open interval, then you can say that, then you will be able to find out a point between A and B where the instantaneous velocity is equals to the average velocity in that interval. That's fine. So that's another way of saying that, okay? So, but there is at least one point C. There may be more than one point C between A and B, that's so that the slope of the tangent is equals to the slope of the secant line joining the endpoints. Let us look at this example. So the fx is that black color curve, okay? So what is the secant line joining the endpoints? This is one endpoint, this is another endpoint. I join that, that's the secant line. Okay, the function is continuous everywhere. The function is differentiable everywhere because there is no sat corner or cusp, anything there in both cases, right? So we will be able to find out at least one point C where the slope of the tangent line is, or the tangent line is parallel to the line joining the endpoints, right? Or the secant line joining the endpoints. Look at this. This is one point C. Here, the tangent at the point C is parallel to that, and there is another point C, I denoted by C1 and C2, where the tangent line is parallel to the secant line. Okay, that's what the mean value theorem says. Okay, let us do some examples, then it will be clear for you. Determine if the mean value theorem can be applied to fx equals to x plus 5 over x minus 2. What is given is f of x equals to given as x plus 5 over x minus 2. The interval is -8 to 8. Do you think this function is continuous in at all the points between -8 and 8, including -8 and 8? The answer is no. Why? Because if you solve the denominator here, then at x equals to 2, the function does not define, right? At x equals to, the function is not defined. Since the function is not defined, there is a break. It is not continuous. So how do you write that? Since f of x is undefined at x equals to 2, because there is a 0 in the denominator. For x equals 2, there will be 0 in the denominator. That means it is infinity. The overall fraction will be infinity, right? So f of x is not continuous at x equals to 2, but the mean value theorem says that it must be continuous at all points between A and B. So hence The mean value theorem we denote by MVT, mean value theorem, is not applicable in the interval -8 to 8. If it was picked like, if it was 4 to 8, it would be applicable though. But in -8 to 8, it is not applicable. So the answer is no. Okay. So if yes, find C, but it is no, right? So C is not available, not applicable. Since the Rolle's theorem is not applicable, so there is no such C, not available. Okay. Let us do another example. Determine if mean value theorem can be applied for fx equals to 5 cosine x on the interval 0 to pi. If yes, find C. So what is fx? So f of x is equals to 5 cosine of x. So this function is continuous everywhere. This function is, oh, by the way, I forgot to give the, oh, there is interval on 0 to pi. So the function cosine x is differentiable everywhere. The function cosine x is continuous everywhere. So we are okay to use the mean value theorem. Then continuous and differentiable everywhere. So it will be continuous and differentiable on this interval too. So by the mean value theorem, you can write f prime of C equals to f of pi minus f at 0 over pi minus 0, right? So what does this imply? What is fx is 5 cosine x. What will be f prime of C? So the f prime here basically, so f prime of x will be -5 sine x, right? So what is f prime of C? That will be -5 cosine C, -5 sine C equals to, what is f at pi? F at pi is, you replace x by pi. 5 cosine pi is -1. So it will be -5 minus f at 0. If you replace x by 0, you will get 5 cosine 0 is just 5. Divide by pi minus 0, right? So what do you get? Basically, you got, it is -10 over pi. You see that? So what do you get? You got -5 sine C equals to -10 over pi. So what I'm trying to do is I'm dividing by -5. Let's do that. Divide by -5. Divide by -5. What do you get? You got sine C equals to 2 over pi, right? So you'll get, this implies, let me start here. Sine C equals to 2 over pi. So how do you solve for C? You take sine, arc sine on both sides, right? So C equals to arc sine, or you can do inverse sine. Arc sine 2 over pi. So if I use calculator, I will get C equals to 0.69, 0.69 and then 0.1. This is what I get.